All right, today we've got section 2.2, day 3, our last day for section 2.2. Our objective today is going to be to write even more equations. This time we will use point-slope form. So we're introducing a third form for linear equations. All right, point-slope form for the equation of a line. The line through two given points with slope m has the equation y minus y1 is equal to m times the quantity x minus x1. So when they write this, those 2 points that they talk about up here, remember we usually label the points like x1 comma y1 and x2 comma y2. So you will be using both of the points to find the slope m, which we've practiced that before. And then you're going to use one of the points to plug into the y1 and the x1. The plane y and the plane x, you leave those alone. Okay. All right, our first example, write an equation in point-slope form using the two given points. Our first step on all of these, if we're given 2 points, is going to be to find the slope. If before you get started you want to put like a little x1, y1, x2, y2 above these, go ahead and do that. If you also want to write out the formula for slope somewhere where you can see it, go ahead and do that too. So I'll try to, I'm going to have to erase some of the directions to fit it up here. So remember to find slope, m equals y2 minus y1 over x2 minus x1. You remember doing that a couple days ago? Hopefully. Okay. All right, so we're going to find our slope first. So m equals, what am I plugging in for y2? Negative 1 minus 5
minus 5
over
4 minus 1.
4 minus 1.
In the form for you.
And in the denominator?
2.
Wonderful. That's going to reduce to negative 2. So we know our slope is negative 2. Then we're going to go to that point-slope form, which we just talked about on the previous slide. Y minus y1 equals m parentheses x minus x1. Just barely fit that all in there. So there's nothing getting substituted in for the plane y, nothing getting substituted in for the plane x. So we have y minus. At this point, you can pick whichever point you want to work with. Just to be consistent, I'm going to use the one that I labeled with the 1s. If you would rather use the other point, technically that's fine. It will look different when you write it. So I'm going to do y minus 5 equals, my m or my slope was negative 2, so I use that. Parentheses, x minus x1 was 1. Now, if you were to use the other point, you have to use both coordinates from the other point. You cannot mix and match. When you plug in down here, you have to be consistent. And that's it. That's my answer. We wanted an equation written in point-slope form. Okay, so since all they wanted was point-slope form, we stop there. We do not have to convert it into another form yet. At some point, maybe we will. All right, on number 2, again, my first order of business is going to be to find my slope. Q, what am I going to plug into my numerator? So what's going in my numerator or in the top when I try to find slope on number 2?
Oh, negative 10 and Q, negative 2.
In my numerator?
Oh, no. Okay. Is it 17 and -1?
Yeah, so 17 minus -1. And then the other part is what goes in our denominator, the -10 minus -2. You can. If you would rather write plus instead of subtracting a negative, that's fine. Charles, what do I get in my numerator?
16.
Close. Remember, subtracting a negative means we're really adding one. 18. And still Charles, what do I get in my denominator?
-4.
You're right, it would be negative. I think -8 sounds good. You will, of course, want to reduce this. I'm going to pull my negative sign out in front of it. You don't have to do that. It's just good practice. These are both divisible by 2, so that gives me 9/4. Negative 9/4 is my slope. I like using the first point, keeps it consistent. So we are now going to use the slope and this point to plug into point slope form. So I'm going to do that all the way up here so I've got some space. Point slope form is y minus y1. But my y1 is negative, so really it's going to be plus 1. Okay, if you have to write it as minus a negative first to see that, that's fine. You can do that. Equals, I plug in my slope. Negative 9/4 times x minus x1. So really, it turns into a plus 2. Okay, so this was x minus -2. That's where we got x plus 2 from. You have to be careful with your signs on these. And then that's it. We got it in point slope form. That was all we were asked to do. We can stop there. Easy. Okay, so on number 3, I start off finding my slope. Ian, what's going to go in my numerator when I find slope? Very good. -3 minus 1. And what about the denominator? Yes, please.
-4 minus 9.
Wonderful. All right, Caden, what did you get in the numerator? -4. And in the denominator? Wonderful. But we all know a negative over a negative is really a positive. So I would write this as positive 4/9. Just to be consistent, we'll keep using the first point in our point slope form. Technically, you can use either of them. So I have y minus 1 equals my slope 4/9 times x minus 5. We have it in point slope form. We're all finished. All right, on your notes, you've got these little boxes for these notes to go in. So this information here is what's going in those boxes. We are dealing with parallel and perpendicular lines. Parallel lines always have the exact same slope. Perpendicular lines have slopes that are opposite reciprocals, which means their sign is different. One's positive, one's negative. And they are reciprocals at the same time, meaning that we write it as a fraction and then we have to flip it. So both of those things happen at the same time if the lines are perpendicular. All right, on example 4, we are writing an equation in slope-intercept form. So now we start paying attention to what form we want it in, meaning we should always read our directions. Right? Yes, okay. All right, so in slope-intercept form, we're going to have two ways of going about it. We can do it like we did yesterday, where we plug in x, y, and m, and then solve for b, or we can put it in point slope form and then convert it. You kind of just have to pick your favorite way and stick with it. Part of it depends on what the slope is. If the slope is a fraction, sometimes that makes one way easier than the other. But let's just look at this problem. So we're given a point, and we are given another line. So it's parallel to y equals negative 2x plus 7. What is the slope? Alexis, what is the slope of this line here? What's our m in this line? Negative 2. Our slope here is negative 2. And if we want a line that's parallel to it, we want to use the exact same slope. So we are also going to have a slope of negative 2. The exact same slope. I'm going to show you both ways of doing this problem. So I will show you using what we did yesterday for slope-intercept, and then I will show you going through point slope form first. You can choose what works best for you as long as your answer is in the correct form. Okay, so doing what we did yesterday, we have x and y. So we plugged in our y, the m, and the x to y equals mx plus b, and we solved for b. So 4 equals negative 4 plus b, therefore b equals 8.
That would be a positive 4.
Alright, so let's back it up. Positive 4. Glad to know we're all paying attention, or at least 3 of you are. So b equals what? 0. Alright. So we go to put it in slope-intercept form. When we go to write our answer, it's y equals mx plus b. We plug in the m and the b, but do we need to put a plus 0 on the end of that? No, we don't. So we'll just leave it there. Okay, so we've done that problem. Technically at this point we can move on, but I want to show you the alternative way of doing the same problem.
Which was easier?
It's kind of up to you, and it kind of depends on the slope which way is easier. So the way of doing it, going through point slope form first, we just start plugging everything in. Y minus y1 is equal to m times the quantity x plus 2. Right? It's a plus 2 because our x was negative. Subtracting a negative means we're adding. Alright, but we're not done because this is point slope form and we want slope intercept form. So the first thing we have to do now is distribute that negative 2. So we have y minus 4 equals negative 2x minus 4. And then to get y all alone, we add 4 to both sides. So y equals negative 2x plus 0. Either way, we get the same answer. So you can kind of pick which way you prefer to do it, as long as you're paying attention in the directions to what your final answer should be in. 2 ways of doing the same problem. We won't do this one both ways. We'll just pick a way and do this problem.
The new way.
The new way? Okay. We can do it that way. Alright. This one, we have a point we're going through, and it's going to be perpendicular to this line that they gave us. So, kind of like off in a little thought bubble, I just want to block this off. and think about what is the slope of this line right here. Sadia,
3/4.
3/4. But I am perpendicular to that slope, so I don't want to use that slope. I want to use the opposite reciprocal of it. Ajaya, what do you think for the opposite reciprocal? Positive or negative? Negative 4/3. So the slope I want to use is the opposite of it and the reciprocal of it at the same time. So negative 4/3. All right, so now we're basically just all done with this. We don't really care about any of that anymore. We got the information we needed from it. We can just set it aside. What we want to focus on now is the point that they gave us and the slope that we decided we need. I had a request to do it the new way. So we are going to go through point slope form and then into slope intercept form. We'll just see how this works out. So here's my x1, y1. Point slope form. I'm going to have y minus y1 is 1 equals, my slope is negative 4/3 times x minus, the x1 is 6. In order to keep going with this, we are going to have to distribute this negative 4/3. So we have y minus 1 equals negative 4/3 x. A negative times a negative means it's going to end up positive.
How do you multiply that?
It would end up, it would end up being 8. 4 times 6 is 24, divided by 3 is 8.
Oh.
If you have a calculator, you can use a calculator to help you out. 4/3 times 6. But y is not by itself yet. What do we still have to do?
Add the 1.
Add the 1. So our final answer is y equals negative 4/3 x plus 9. If you did it the other way that we talked about yesterday with plugging in y, m, and x and solving for b and then rewriting your final answer, you should end up with the exact same thing. What we need to know about horizontal lines is that the slope is always 0 and that horizontal lines are perpendicular to vertical lines. Now, this is something we probably should have touched on a little bit earlier in this lesson, but can anybody raise their hand and tell me what it means to be perpendicular? Kaylin?
Without ever touching.
That's parallel. What's perpendicular?
The opposite.
Sort of. Emily? They intersect at one point. Sadia, what are we missing?
They. Crap, never mind, I forgot it. They're right.
Okay, Emily remembered it. We intersect at a right angle. So parallel lines never touch each other, but perpendicular lines cross at right angles. And sometimes that just looks like a cross or a plus sign. Sometimes it can be at an angle, looks like an X. But no matter what, perpendicular lines cross at right angles. So for horizontal lines and vertical lines, that's going to look like this option here. A horizontal line and a vertical line will always be perpendicular. Does anybody need more time on this slide? Okay. Then let's go on to vertical lines. For vertical lines, the slope is always undefined. I think we saw an example of that doing slope earlier this week. And vertical lines are perpendicular to horizontal lines. It's not really new information, we're just stating it the other way. All right, let's do some examples. First, we want to write an equation in slope-intercept form for a line through the point negative 3, 7, and we want that line to be horizontal. Okay. If it's horizontal, I know that m equals 0. I have to just know that. If it's a horizontal line, m equals 0. Okay, so we can proceed with writing an equation. This time I'm going to do it like we did yesterday for the slope-intercept. So I'm going to plug in my 7 for y, my 0 for m, my negative 3 for x, plus b on the end. B is going to end up being, anybody? 7, right? 0 times negative 3 is 0. That just leaves b. B equals 7. So I go to write my equation. I think we saw one like this yesterday or the day before. Y equals 0x plus 7. Do we really need to put 0x?
No.
No, I can just write y equals 7. And that's it. That is the equation of my line. And technically that is considered slope-intercept form. On number 7, so it's through that same point, but it's vertical. So what's our slope?
Undefined.
Our slope's undefined. So that's not very useful, right?
That would make the problem.
N is undefined. Yeah. Right? Y equals 7, goes through 7 on the y-axis. This line doesn't go through the y-axis. Which axis does it go through?
X.
The x-axis at
3.
negative 3. Okay, so this line's equation is actually going to just be x equals negative 3. There's no real good way of solving for that like we did up here. We could go through all of our steps. For vertical lines, this is something we just kind of have to know. The visualization can help us figure that out. Like, oh, it crosses the x-axis at negative 3. So x equals negative 3. But when our slope is undefined, we can't really plug it in and solve like we can when our slope is 0. I think equations of vertical lines are some of the hardest ones for students to remember. So, to sum things up, really just hit it home. Horizontal lines will always have an equation of the form y equals a number, not a hashtag. This is a number. I'll write that in there for those of you that aren't sure. A number, not a hashtag. Vertical lines will always have the form of x equals a number,
Hashtag.
not a hashtag. Okay. That's just kind of a wrap up. Commit that to memory, memorize it, love it, use it, all those good things.